thank you so much for being here. We really appreciate you guys. This is going to be a very interesting session. Today we're going to be talking about streaming telemetry. So I'm not sure if you guys are familiar with streaming telemetry, but just want to set the right expectations so everyone knows. This is about model-driven telemetry. gRPC is the name of the protocol. So basically, streaming your data, pushing the data from your wireless infrastructure to your collectors in the cloud or on-prem. It's a completely different shift and way of monitoring your infrastructure. So we're going to be talking about that today. We have a WebEx room. In case you have any questions, feel free to go to that WebEx room, and we have live moderators that will be able to answer the questions. Or even after the session, if you have any question, you can always go to WebEx, and we can answer your questions. Or after the session is done, we can catch up here and talk more about it, exchange emails, and then we can, stay in touch. Now about Deepak.
Yeah, hi everyone. My name is Deepak, and I am an escalation engineer with Catalyst Center team based here in Richardson, Texas. I was born and raised in north part of India, and I have been in wireless industry for last 14 plus years and have been in my current role for last 3 years. And these are some of my passions: traveling with family, enjoying with kids, cooking in my part-time, and then playing cricket and volunteering for any activities.
Cool. And I'm Rafael, originally from the Dominican Republic, born and raised there, now living in the state of Washington, Seattle suburbs. I've been on tech for a very long time, doing different stuff, everything around enterprise networking for the most part. And some of my passions, sport with the kids. Now my kids are teenagers, so I spend as much time as I can with them because they're going out soon. Reading, swimming, traveling, and also organizing give-back activities in the state of Washington and also outside of the United States. So those are some of my passions. So let's get into the conversation now. So what is our agenda for today? We're going to be covering a lot of stuff. I will be covering from point 1 to point number 5. Right? I'm not going to read through the agenda. It's there. We're going to discuss about it. And then Deepak will go from point number 6 to point number 10. So let's get started with the first topic. Why model-driven telemetry? So, back in the days, in the, early and late 90s, we were pretty good, working with CLI, monitoring even our infrastructure and doing a lot of troubleshooting and doing so many things through the CLI. So that was back then the norm. Then we went to, a pooling with SNMP, right? So we were very good with MIPS. I know MIPS, they're still used today. Many customers are still using it, but that was the norm. And then things started to get a little bit better, early 2000s, 2010, and even today, many people are using syslog. Many people are using now traps with SNMP and NetFlow. But there's this new thing called streaming telemetry, and it's model-driven telemetry. It's dialed out from your controllers, wireless LAN controllers, to your infrastructure that is monitoring the network outside of the controllers, right? So that's what we're going to be talking about today. Is the best solution now to basically monitor your infrastructure and get almost real-time KPIs and metrics about your wireless infrastructure. A good thing about this, and that's a limitation that we have with majority of the other solutions, this actually can scale. It can scale to hundreds or thousands of sites. It can scale to thousands of devices as well. So if you build the right infrastructure, this is a very scalable solution. And you can actually, we have this solution working with a very big customer where they have thousands of controllers and hundreds of thousands of access points. So it's a proven solution that actually can scale and work pretty well to monitor your infrastructure. Now, why driven telemetry? It's like you're moving away from the old way of monitoring with a bunch of false positive alarms with SNMP, and also you move away from the CLI because you now have all the KPIs and metrics that you get. If you don't get it via SNMP, you will get it then via CLI, and you need to check around CLI. All that you get it, with telemetry. And then you move away also from multiple management and monitoring tools. Now you're injecting everything via model-driven telemetry to your collectors, to your infrastructure, to monitor your wireless infrastructure. So now you don't need to have multiple tools, to manage your infrastructure. Now, there's still a big play for syslog because remember, you're building a connection, and we will get there. You're building multiple connection from your controllers to your collectors sitting in the cloud, and in case one of those connections, they go down, you can still get value with syslog to know at what given moment that connection went down, right? Because it's gonna happen. Sometimes your collectors might go down or your load balancers might go down. So you still want to be able to monitor via syslog. Now, what does the North Star look like in the future? And we are seeing customer moving in this direction. The North Star is starting to monitor via gRPC with TLS or MTLS, mutual TLS, encrypting your data, right? That's number one. Number two, using to automate your infrastructure, netconf or restconf, right? To dial in to your controllers with netconf and restconf, and also get data via syslog to monitor the state of your connections, and also encrypting that data of your syslog via TLS. So this is the North Star, and this is where we're seeing customer moving towards with, because now that you're getting all this data, you can build your own automation, right? It can be homegrown, or you can buy it from a vendor, and you can build your home automation and build your own self-healing and auto remediation based on your needs. So this is where people are moving towards with automation. And now that we're always talking about AI and we're talking about all these LLM models, this is the right timing to start building towards automation. Build your own scripts, your own tools, even your own software, if you like, to move towards automation and start getting your infrastructure to do some of the things that you're getting from those KPIs and metrics. A bit more about those KPIs and metrics that you get. I have touched a little bit on this. You get all your client stats, everything around roaming, everything about your hardware inventory, how often it's changing, everything about the state of your access points, controller, retransmission, noise, data rates, everything you get via streaming telemetry. You have full visibility about your infrastructure, about your network, and as I mentioned, there's no false positive here. Everything you're getting it as it happens in your wireless infrastructure, because these are based on specific metrics and KPIs that are being collected directly from the controller. It's like if you're doing a CLI, and that CLI is being transformed to be able to send on that specific time those metrics that you just saw on the CLI, right? So all that is being collected on the controller is being sent to your collectors that are basically getting all the data from your infrastructure. Now, getting more about model-driven telemetry so you can understand better how this works. There are multiple ways here that you can dial in to be able to make changes to the infrastructure. One is netconf, the other one is restconf. GNMI is another one, which actually also now support dial out starting in 17.11, and then gRPC, right, for dial out only. And today we're going to be concentrating for the most part on gRPC. So gRPC is the protocol that you will be using to basically integrate the monitoring of your infrastructure with those collectors. So as I said before, there are two models. You can go with GNMI if you want to do dial in and dial out. GNMI basically is also using gRPC for dial out, or you just are using, let's say, netconf, or you're using restconf already, and you just want to dial out, then you go with gRPC for dial out. One thing important to note is that gRPC basically works on HTTP2. It works on a TCP socket, and you can just go TCP and you don't encrypt the data, but we strongly recommend to always go with TLS or MTLS to encrypt the data. MTLS would be the best option, so you're encrypting on both sides, the client side, which is the controller, and the collector side, right? So certificates are being exchanged, or you can just go TLS and encrypt on the server side. our entire portfolio, with the exception of Meraki, support streaming telemetry, gRPC. Support for Meraki is coming this year, very soon, but it's on the roadmap already. And we also recommend, gRPC can work on any port, but we strongly recommend to go with 443. And then this is the concept, one of the most important concepts, because I've been talking about gRPC, streaming the data, right? But what are you streaming? You basically are streaming different YAM models that are actually have all the measurements and KPIs and metrics that you want to receive on your collectors. So let's say, okay, I want to get all the stats of all my clients. There's going to be one XPath for that. So that XPath is basically a YAM model, and that YAM model contains everything about the client stats of all the clients that are attached in your wireless infrastructure. So you will be getting all that data in your collectors. That will be dumped into a database, and then you can use multiple tools to be able to visualize that data, and we will go and show those as well. And there are two ways here of actually monitoring the infrastructure with gRPC. One is on change. Whenever something changes on the network, then you're going to be receiving that data in your collector. And then the other one is based on different time periods. So whenever let's say, okay, I want to receive all the stats of my clients every 60 seconds, but I want to get all the stats of my access points and wireless LAN controller health of the APs and controllers let's say every 5 minutes. So you can define that time period of how often you want to receive the data. Something to actually note here is that we don't, for all the XPaths, right, all those YAM models where we have all the metrics and KPIs, we don't support all of them on change. So there are certain XPaths that are not supported on change, but all the XPaths are supported on periodic time, periodic sequence. A bit more about how this is going to look like. So on top, you have your infrastructure. Let's say your wireless infrastructure. This is also supported on switching as well and routing as well. But for today's session, we're mostly concentrating on wireless. You have your load balancers. You can use any load balancers, on-premise, open source. This is a few open source options. But also, you can, if you're sitting in the cloud, you can use your load balancer from your cloud vendor, or if you're on-premise on some data centers, you can use also your load balancers for that. So there's no issue on which load balancers you use. Then you have the collectors. We strongly recommend Telegraph. Telegraph has been certified at scale. Some customers, I know they're building their own, but Telegraph is already there. It has pretty good support from the community, and you can integrate it pretty easily. And then for monitoring and time series database, we strongly also recommend Splunk. It has been tested at scale as well. Many of our biggest customers are using it to send alarms, alerts, and visualize the data. But as well, you can go with any other that you like without any problem. Now, the reason why we recommend Strong is because there is a lot of flexibility around, Splunk here, right? To be able to index the data and forward the data to third-party tools, right? So that's where we have seen the big value of Splunk. Even when we started doing lab in the beginning, and where we were able to show that to some of our biggest customers, they like the fact that, they can send the data, consume it, but also send it, let's say, to the InfoSec team, or send it, let's say, to the whatever team, or any other team that wants to know more about the infrastructure. So that's the big value there. Okay, so I forgot to tell you guys about this, but we have some swag here. So whoever gets the right answer is going to get a goodie from us. So this is a question that we have for the audience. Whoever raised a hand and would like to get something cool from us, let us know, and Deepak will go ahead and give you this, gift. So who has the right answer? Which one? A? No. B is the right answer.
Okay.
So the gentleman in the back, he got it right. So I forgot to tell you that, guys, but during the session, we're going to be asking some questions, and there will be an opportunity for you guys to get some swag today. So just be ready for it. Now, getting into model-driven telemetry connection state flow, and this is very important. There is going to be a question that's going to come from this topic, okay? I'll just give you a heads up so you can get ready. This is very important here because I told you that they are expats. The expats are the young models that actually have all the KPIs and metrics that you want to send from your wireless infrastructure, right, to your collectors. So that infrastructure, right, those expats, they need to build a gRPC connection individually with your collectors. As I said before, the connection can be TCP, not encrypted, or it can be MTLS or TLS encrypted. We strongly recommend, remember, to go encrypted. That time period, those 15 seconds, it goes from the disconnect all the way to the connect time. We also recommend to go with FQDN. The reason why we recommend FQDN is because if you go with static IP and your collectors goes down, right? I mean, the collectors are with static IPs, and you won't be able to change it. You will only be able to change it manually on your collector. So that we recommend to go with FQDN because in case an IP address goes down, it doesn't show up anymore in your FQDN strategy or your FQDN host, right? So we strongly recommend to go FQDN. So in this specific case, we have 70 expats. Those expats, because they're doing a FQDN DNS discovery, they actually go and will find the IP available. So they will randomly go to different controllers, okay? This is very important, right? You have 70 expats. Not all the expats will always go to the same controller because they're doing a DNS discovery, and not every time the same IP will come up, right? So they will be attaching and building that connection to different, collectors. So let's say collector 4 went down, right? Collector 4 is down now. So what will happen? There were 10 expats in that collector. Those collectors, then this 15 seconds period is going to restart here because those 10 expats that went down, they're going to do again a DNS discovery to find on the FQDN the collectors available to reattach to a new collector, right? Because one collector went down. So this is what is going to happen here. Those 10 expats will do now, again, a DNS resolution via the FQDN to try to find the next IPs available, the next collector availables. And then when that happens, the 10 expats will build a new connection with the collectors. Still, collector 4 will be down. It doesn't matter. The 10 expats that were in that collector are already attached to other collectors available. And collector 4 can come up again. It doesn't matter. He's fine. He probably doesn't have any expat at the moment. But if one of the other collectors goes down, then the expats can find again the collector 4 to reattach to that collector. So that's how the logic works. And that's how you build actually the redundancy with FQDN. All right. So question number 2. What will be the answer here? You got it right. Number C. All right. Cool. So, yeah, don't worry, guys. We have more questions coming, so it's gonna keep getting just excited. Okay. So design considerations when you're building, your streaming telemetry, MDT. I would say infrastructure, a monitoring tool. Always think about, securing your transport. You guys have seen that we have emphasized a lot around securing that transport with TLS or MTLS. I don't want to get into details, but one of our customers said, "Oh, why somebody will need our data? Like, why they will need it?" So they decided not to encrypt it, and then they got a flag from InfoSec team saying that some of their data were being taken out of the network because they thought that because it was internal data, nobody would take it out, so they got in trouble. So I will always tell you, encrypt your data It doesn't matter if it's traveling internally within your network. The second thing, as I mentioned, and I have talked about this already, FQDN, define your FQDN strategy, where you will have your collectors, different regions, different data centers for, where you're gonna place them, and then have multiple IPs available, so in case one collector goes down, then others are available. And then the last one, think about redundancy, right? If you're going, let's say, always think about multiple load balancers, right? Think about having multi-region redundancy or multi-data center redundancy. And think about load balancing that traffic across multiple collectors across different data centers, right? So that's very important so you can build a better redundancy. This is a customer reference architecture. This is from a customer, a big customer that has implemented this in AWS. There are many ways of doing it. They decided to basically build their collectors using Kubernetes and Dockers and all that, containers, but you can easily go with EC2 instances in AWS, or you can do the same thing in Azure or any other cloud that, of your preference. But this is just, from a customer that they decided to go with AWS. And same thing on-premise. Like, you can use ICE, as your certificate manager or any other certificate manager tool that you may have and build the same infrastructure on-premise. No issue about that. And have it across multiple data centers, right? So this is another way of doing the same thing. Now, third question here. The person in the... Yep, that's the right answer, B. All right, so now getting into the telemetry design at scale. And this is very interesting. So I will touch bases here, from a small design, from very, very small design, all the way to a very big design, okay? A large design where you have thousands of devices. So this is, I would say, this is for a small design, right? Think about just 20 to 40 offices, right? Where you, let's say you're doing Flex Connect and you're having a centralized deployment of your wireless LAN controllers in your data center. This is gonna work fine for you. I mean, if you have your collectors in your data center and you're doing Flex Connect and all your remote offices are going to your, controllers, you can have also the collector sitting where your wireless LAN controllers are. Or if you have controllers on each office, then you can centralize these collectors in your data centers or your cloud, right? So this is, I would say this is a good design. A very small design in that way. As I mentioned before, FQDN always encrypt the data. In this case, as you can see, there is a certificate exchange between the collectors and the controllers. So this is MTLS, right? So the only downsides of this solution is that you will need to manage a lot of certificates if you decided to do it this way, right? With this small deployment. This is a completely different solution, so this is a little bit more scalable. This is actually adding now load balancers. Some customers, they decide to do active-active, others they just decide active standby. It's gonna work fine, with you. The difference in the design between this one and the other one now is that the load balancer are up front, but still the certificate exchange is happening between your controllers and your collectors, right? The load balancers, they're just managing this session and where that gRPC session should go to which collector, but the certificate exchange to build actually that tunnel happens between your collectors and the wireless LAN controller. Then this design is different now. So now you're having less certificates because the certificate exchange happened between your load balancers and the collectors. So less certs to manage. Everything is happening on the front end in your load balancers. And then in the back end, the load balancers and your collectors, it can be sitting in the same region or the same data center. That's a TCP connection to send the data there. If you want to, you can also do MTLS there, but it's gonna be a lot of certs to manage just in case. But that should not be a problem, but you can do it. And then The last one, well, this is the same as the other one. This is just active now. The other ones was active standby, but this is an active design. I would say this is more common to see it. And then the last one, and I would say this one I have only seen once with a very large customer. This design is like on a different level where you will have front-end load balancers and back-end load balancers. The front end are, let's say, will have, exposed to public IPs. And then on the back end, you will have private IPs. This is going to be, in some cases, you will see this design when, the load balancers are just sitting on the public internet. I have not seen this much, but it's a design that is out there, and I have seen it, for a very large customer. So yeah, just think about the way you will deploy it, because there are many ways that this can go, and you want to make sure that whenever you're building your design, you're building it the right way. Cool. So now we will get into performance and validation, and Mr. Deepak will be covering that.
Thanks, Raf. So in the first half of the session, we talked about design considerations, introduction to MTD, and some of the telemetry design at scale. In the second half, we will be talking about performance and validation, some real-world scenarios, a story at Cisco Live, an interesting one, and also some key takeaways. So in the past few years, based on the feedback that we got from customers and also some in-house testing, we came up with some scale design considerations that work very well. So the first one is that maximum subscriptions on 9800 WLCs, they are 150, out of which 85 to 90 will be consumed by Catalyst Center, and 10 to 12 will be consumed by Cisco Spaces. So you need to factor in these subscription limits based on what existing subscriptions you already have on the controllers. Now the third one is subscribe to the closest leaf possible, because we want to avoid putting any oversubscription state or putting any kind of overstress on the existing subscriptions that are there on the system. Also, we need to monitor the PUBD process for CPU to balance subscriptions, because even if overall the processes are not high, but there would be few processes that might be consuming above their thresholds. In high-density environments, be it enterprise, colleges, universities, where clients tend to roam very frequently, you will see very high roaming client rates. So, and they actually have impact on the performance, so you also need to keep an eye on those. Also, as Raf mentioned in the first half of the session, that you need gRPC MTLS for it, so just make sure that the certificates, they are not expired or they are not near to their renewal state. This is a simple setup that we built house in our lab, where we just took 2 controllers, 3 collectors, 2 DBs, and with the help of some scripts and based on Jenkins, we just put it on Splunk and Grafana to build a dashboard. Now, anything that we suggest to customers, okay, every time customers are like, that if you are giving us these recommendations, have you tested them in-house? So this is what we did in-house with the help of wireless PU team, that we built a high-scale setup where we use simulated clients and simulated APs. Here, as you can look like that, the total simulated clients, okay, that was sending traffic, that scale was up to 64,000. And we used around 6,000 simulated APs to generate that traffic. Also, we took in consideration the roaming rates just to test if the clients, they are having a high roaming rate, then what is the performance of the system. And there the team validated around 300 to 400 roaming per second. And then also we used few XRE traffic generators, okay, to generate more traffic, where the limits that were tested, they were close to 10 gig, 20 gig, 30 gig. And this is just the output that we have attached. And we used almost 25 expat subscriptions, the important ones that we believe are the very common ones that are used by most of the customers or high-scale customers. So we used those ones. These are, again, the outputs. Now, For your reference, okay, again, based on our in-house testing and the feedback we got from some of our customers, okay, we got the list of these 25 important subscriptions, the expat subscriptions that most of the customers, they use in their environment. And the time limits that you see in next to them, these are the scale intervals, okay? So any expat that you are using, you just need to keep in mind that you use the scale interval for that. The one that requires 60 seconds, just use it for 60 seconds. The one that requires 15 minutes, use it for 15 minutes. Now, based on the recommendation of wireless code, like what the iOS XE code that you should be running, you can run anything around 17.12 where exactly it starts to support. But as per our recommendation, we suggest either you run 17.15.3 or anything higher in any further train that is a recommended code. Okay, and now we have this question.
All right, who want to raise your hand? You hear it? Do you hear the answer?
Yeah,
D, right?
it's D. D, right?
You got it right. You're welcome.
Okay, so now let's talk about some real-world scenarios. Suppose you are in a situation where everything was working fine till last night or maybe today morning, and suddenly you get a call from your teammate or somebody that there is a problem. Okay, it could be a client problem, the controller has crashed, the AP has crashed, or there could be some performance or scale issues that are happening in the network. Now, based on that, we need to first answer or get some information that actually helps to root cause the problem. In my 12 to 13 years of wireless experience, most of the time, whatever I'm going to cover in this slide, okay, that's probably like 80% of the information that helps to root cause the problem. If you get to find the right information based on the right set of questions to identify the problem, it's like very good enough to understand what's the problem and probably what the root cause of it. So first one is what changed in the network, okay? We probably need to understand, did we add any new member from device perspective? Was there a config change? Either you did it or somebody from other team did it, or there was a new solution that you introduced. Suppose you just started to use some third-party tool, right? Just to get some client data. And it is just hitting the system with APIs. You are sending the same API, maybe 50 times, 55 times in 4 or 5 minutes, okay? And that's just putting pressure on the system, putting stress on the system. So that is something that can actually impact the performance of the device. It could be a new hardware that you added. Also, there could be a software update. You just basically upgraded the device, and that is when you started to see the problem. Now, this is the second output that basically helps a lot. I mean, Showtech or Showtech Wireless. And in addition to that, if you have the expat config that you can get, that will definitely help you in isolating the problem. This is very helpful from client connectivity part. Anytime you see any kind of client disconnectivity or any client issues, okay, you can just get a RA trace, AP debug, or a PCAP from controller. At the same time, we have this functionality available on Catalyst Center as well, that you can trigger these outputs directly from Catalyst Center. And then based on archive logs, what actually happened in the past? Did someone make some change, or what kind of change that happened? Definitely you can get that captured. That will be captured in archive logs, so they are very helpful. And then you can also do these with the help of tools, scripts, third-party tools, or some other tools. And this is the most important part. This is what is our session based on telemetry data stats. And that is what we are going to cover in the next few slides, where you will understand the power of this solution, how exactly it helps in big scale environments, and what is the benefit of using it. Now, everybody uses different type of building blocks. I mean, every customer has their own requirement, whether they want to, which type of data they want to monitor or which process they want to monitor. But based on our learnings, we came up with few important ones that will actually help you in day-to-day life troubleshooting scenarios. The first one is CPU and memory monitoring. You actually need to understand what is happening on the device from CPU and memory perspective. Is there any process that is consuming too much, or the overall system is above its CPU or memory limits? Second one is the control plane. You need to understand if there is any process in the control plane that is actually like consuming any high limit. Then comes the data plane. Most of the time, you don't see the problem, but in my experience, there are scenarios, it could be in a university environment, somebody just like from one point to the other, just configured some low fragmentation packets. It could cause some stress on the system where it's kind of like a situation, low packets versus high fragmented packets. And then definitely the client states. You need to understand if there is anything that is going on with the clients from DSCP perspective, it could be from authentication perspective. And then general environmental monitoring. You also want to understand if there is anything that is wrong with the hardware of the device, like the fan status of the device, if the power cable is faulty on the device, or if the temperature of the device is high. So you can get all that information in this. And then definitely the RF stats. If the clients are roaming too much, there is high channel utilization, there is kind of noise, you have rogues, that is where this comes in handy. And this is some of the outputs that we have captured, and also the XPath for it, for your reference. And this one, like I talked about, this is for the monitor and track CPU memory. And this is our WNCD dashboard that we generally use for IOSXE. As you can see over here, that it has different details and pretty much give you a clear picture about what is going on with the CPU and the memory. This is our track MDNS scale, one example. So as you might be knowing, when Apple initially introduced MDNS, okay, and as soon as you enable MDNS in your system, it's going to like broadcast on all the RF domains. Because there at that time, we didn't have the option of using LSS. And that is where, when Apple realized that if you enable MDNS, okay, then this is what actually happens on the system. You can see that spike, just because that there were no RF domains that can be regulated, and there was no LSS config to control this. This is our control plane monitoring. Basically, that talks about the states of client, DSCP timeouts, keep stats, any authentication that is going on, or any kind of client behavior. And again, these are some set of commands and the XPaths for it. Again, control plane, okay. So this is interesting. These are some of the control plane delete reason codes, like in the control plane monitoring. Like for example, if the client, okay, it got deleted. Now you get these delete codes on the system, which you need to understand if they are good, they are bad. So what we did was that we built, like, as you can see, there is a link. We actually built a dashboard where actually you go and it gives you like the information related to what is the meaning of these delete codes. Are these like something that is good, or it is something that needs to be like looked at, or it is something that is actually alarming? So as you can look over here, we have this example where this is like the client roamed successfully. So this is a good code. And these, the red ones, these are the problematic ones. And then this is just like a concern, like not something that is causing anything, but definitely need to be looked at. And this is, again, some of the outputs from our control plane monitoring. And these are for our Radius server failures or latency or any kind of accounting updates that we are seeing. And this is for our high interference in high density environments where you can have rogues or interferers. So we have for this one, this is how it actually looks like, to give you like a fair picture, what exactly is happening, how is like the overall system from RF perspective. And this is for our operational status for the hardware chassis, like I mentioned, the environmental one. And this is for our data plane monitoring. And this one is for roaming stats for the APs. It's for basically the environments which are where clients, they tend to roam at a very higher rate and the roaming rates are very high. This is the environmental sensor that gives you like a fair idea regarding if there is like any kind of fan failure or any kind of temperature that is there, that is a concern. This could be for AP stats. What's happening in the environment from CAPFAP perspective? Are you seeing like the APs getting frequently connected, disconnected? And that actually also generates too many CAPFAP requests and can put stress on the system. And this is for the client load on the APs. Next one is for noise. And this one is for our AP neighbor list. Now, after we have like gone through all these building blocks separately, this is what the real dashboard or overall it looks like. So till now, I was just talking about different things. And then now just imagine that you have everything at one dashboard where you can actually look at these different stats to understand that what is happening in the network. Are you seeing like high count of failed roams? Or are you like actually seeing like high process counts in WNCD? Are they are actually in red zone or they are in green zone? And other key KPIs. Okay, and this one is our other part of the dashboard that we can look at. Okay, question?
D? Okay.
Yeah, that's the right answer. Okay, so let's look at a story at Cisco Live. This happened like 2 years back. So as you can see, okay. So as you can see, let's just look at it. In the morning, people started to come in, okay? Everything was fine from WNCD perspective. There were like thousands of people. And around 12 or 10:30 p.m., okay, it started to climb up, okay? And then around 12, when it was like the peak traffic, when there were like almost close to, okay, and
Don't click. Just let it run once. Yeah.
okay. Yeah, so basically, around 12 p.m., there were like almost 21,000 clients that were online. And suddenly we started to see these spikes. As you can see in the WNCD, okay, before that time, everything was in green zone. But as soon as around 12 p.m., we started to see that WNCD process was actually high and it was in the red zone. So that was something that raised concern for us. What is the reason for this? Why exactly this is happening? So we started to drill down. There were no issues reported at that time. There was nothing like that was highlighted. But still from monitoring perspective, we wanted to understand that what is the cause of this, and if there is a problem that is going to happen, okay, can that be avoided based on this? So we started to drill down, and then basically we just looked at these few matrices, and then after drilling down, we could see that there were these, as you can see over here, that there was like high count of 802.11 management frames, and see, that is where you see high counts of SE auth in association, and then also the invalid PMK IDs. So that means that there was something going on with the roaming of the clients. And that is when we realized that, okay, a new solution that we tested that was enabling WPA2 and WPA3 on the WLAN, okay? And the iOS devices, they need FT transition, okay, to support that, which we have not enabled by that time. So based on this observation, okay, we enabled fast transition. And then the next day, I'll show you in the next slide, that there was like a difference between the failed roam count, which is actually like sitting at 19% right now. And then once we made that change, we were able to like bring everything in green zone. And as you can see that the failed roam percentage also dropped to 1%. Now there were few Android clients also that do not support it, but still majority of the clients were Apple clients. So we have to take that decision. And in that case, what we did was that we moved over those Android clients on open roaming SSID to address this concern and enable fast transition. So this is what the power of this is. Like in high scale environments, okay, that is how, as you can see based on these stats, how basically it helps you to drill down to the problem based on these counters, based on this. Otherwise, it's more of like that somebody reports a problem, you start to ask questions around, okay, and then at certain point, people have to like give you information, and then there is a discussion that starts in, and then that's just add delay to the solution of the problem. I think it's not going forward.
It's not?
Yeah, I think it's just playing it.
Yeah, you go,
Okay,
go
yeah.
back.
So this is like a fair comparison. First half of the picture is when the issue happened, okay, or when we started to see those high roams. And second part of the picture is when we implemented the change and how the overall picture looked. Okay, and this is our full dashboard for the demo, as you can see over here. And this one, I think we have already discussed for the Cisco Live. So yeah, this is just like simple dashboards that I like, different building blocks that I talked about. And this is how it looks like in the full dashboard. So you can just look at it to get a fair picture that how these dashboards, they can be used from navigation perspective to understand that what is going on in the network, okay? What are the KPIs? What are the counters that you are seeing in your network? And are these counters, they are causing any kind of stress on the system? Are they actually in the green zone or they are above their limits? So that is where these dashboards, they come very useful. So these are different expats that we talked about. So this is just like a demo of all these expats when you use in your network, and then you look at the dashboard. So that is how it helps you to understand that. Okay, then okay. And so
You
I
can
think,
just click next.
yeah, that's what I'm doing. I think it's just pausing at some point. Okay, so we have another question.
I don't think he got it first. Which one? Who said B? Sorry, who got it? Who said B? Oh, you. You got it.
Okay. And just to address this concern, this is something that we have added in Catalyst Center now. So starting from 3.2.2 code, you can actually like go into advanced analytics to have these metrics that will be available. These will be basically showing you the CPU processes and everything that we discussed from WNCD perspective. So some of the KPIs we have added here for your reference. 3.2.2. 3.2.2. Yeah. And this is our basically an architecture diagram from lab perspective. As you can see over here, this is the, diagram that you can refer to whenever you want to set up your lab. And we have also like added a demo that basically gives you step-by-step instructions how to set up this thing in lab, and also to try it in-house. These are some of our lab documentation links that we have come up with. These are very thorough. If you go through them, they will give you all the information that you're looking for to set up this in-house, and also what is the, if you want to troubleshoot gRPC or model-driven telemetry and other use cases as well. This is like a 1-hour session that we are giving, so definitely we cannot cover all the useful cases scenario, but this is where you can actually refer to the documentation and you can look at it. Now, these are some of the key takeaways. This is what we have realized, that from monitoring perspective, MTD is actually becoming like a new norm. Like everybody wants to try this in-house, want to get the maximum out of it. And we have also seen that people, they are trying to adopt it very quickly because they understand the power of it, the significance of using it. And also it is a very solid and scalable solution that Cisco is supporting. So we have started to provide good online documentation. If there is any feedback that we get from customers, depending on different use cases, regardless of what is the scale of the environment, we tend to either test those things if we have not tested in-house, and then we update our documentation, or we understand to collaborate with engineering and see that what are the areas of improvement based on the feedback, and we try to improve it. You can always talk to your CX and accounts team for MTD for more information, like what are the upcoming features. Like Raf also mentioned that there will be some features that will be released, and definitely from time to time we are adding new features. So definitely your accounts team is your go-to solution, like where exactly you can get more information. Or you can always get familiar with MTD on DevNet Sandbox. These are our documentation links that you can look at, how to enable telemetry. And if you like any assistance, if you have any question, you can feel free to connect with us after the session. We can try to answer your questions, give you more information. And this is our evaluation. You can just rate our session based on how you liked it, if there were any key takeaways that you felt are good. And also you can continue your education. These are some of the links that you can refer to. And that's it. Thank you.